So this minus 7 can be converted into its 2's complement form by first calculating its 1's complement, then adding 1. So what we get, it is 1001. So minus m, which is minus 7, the value is 1001. Now let us take into consideration how we multiply it using Booth's algorithm. So first we have seen that there are three parameters, that is A stands for accumulator, then Q is what? Q is multiplier, and Q minus 1 is the bit which is initially initialized to 0. So let us see the initialization step. So here A is also initialized to 0, 0, 0. This is the rule, that A should be initialized to 0, 0, 0, or it should be initialized to 0. Then depending on the bits you have to make it 4 bit 0, 5 bit 0, anything. Then what is our Q? Q is nothing but the multiplier. What is the multiplier? It is 3. What is its equivalent? 0, 0, 1, 1. So we have written it as 0, 0, 1, 1. So starting from Q0, Q1, Q2, Q3. Q3 being the MSB, that is the most significant bit. Q1 is initialized to 0, that means the value will be 0. Now initialization step has been performed. So if you remember, count is n. N means what? The number of bits. How many number of bits we have? 1, 2, 3, 4. That means n is what? 4. That means this particular algorithm we will run for 4 passes. We will run this algorithm in 4 steps. Okay. To get the answer correctly, we will have to run the algorithm for 4 steps. Otherwise, we will get an incorrect answer. So let us see the first step. So accumulator is what? 0, 0, 0. Then comes what? 0, 0, 1, 1. Now I would suggest you to keep in front the flow chart that I have shown to you in the earlier slide, and compare. Now what we have to compare? We have to compare this Q0 and Q minus 1 ka bit. Now see, I have compared this Q0, which is 1, and Q minus 1 is 0. This I have compared. When Q0 and Q minus 1 ka value is 1, 0, what we do? We perform A is equal to A minus M. Okay, which means we will subtract M from A. So for earlier we had taken out the minus m ka value. What is the value of minus m? Minus m value is 1, 0, 0, 1. So first we will write A, because we have to subtract m from A. So A is equal to 0, 0, 0. Then minus m. What is the value of minus 1? Minus m, it is 1, 0, 0, 1. We have represented this into its 2's complement form. Now we have to simply add it. Okay, we have to simply add it. So after adding, what we get? We get this C. This 0 plus 1, 1. This 0, 0 as it is. This 0 plus 0, 0. 0 plus 1, 1. So what is there in accumulator now? We have 1, 0, 0, 1 in the accumulator. Okay. So see, this Q will be represented as it is, that is 0, 0, 1, 1 will come down as it is. Only the contents of accumulator will now change. This Q minus 1 is same. Now, after performing A is equal to A minus M, we have to perform arithmetic shift right. Now, to perform arithmetic shift right, I have told you we will shift the bits to right hand side. What are to shift? We have to shift this A ka value, Q ka value, and Q minus 1 ka value. So starting from right. So what is the rightmost? It is Q minus 1. So see this. So see, this 0 will move outside. This 1 will come over here. This 1 will move this side. This 0 will come this side. This 0 has come here. From accumulator, this one has shifted to this part. Now this 0 here, 0 here, this 0 here, this 1 here, and this one again will be represented here, because the last bit is the repetition of the last bit of accumulator. So this is how we got the final string. Now this will be used as the base for second step, or let's say second iteration. So see, as it is, we will write here, that is 1100 in the accumulator, 1001 here, and this q minus 1 is now 1. We have written here 1. So when q0 and q1 का value 1 1 है, so we have to only perform arithmetic shift right. That means we have to only shift the position to the right by 1 place. So see here, this 1 will move outside. Okay, q minus 1 1 will move outside. This q0 will come here, this 0 here, this 0 here, this 1 here. From accumulator, this 0 will come over here, this 0 over here, this 1, and what is the q3 bit in accumulator? It is 1. So this 1 will be repeated again here. So this is the output of second step, which will be used as starting point for step 3. So see, again we have written it as it is, this 1 1 1 0 here, this 0 1 0 0 1 as it is. Now what is the q0 and q1 ka bit? Compare 0 and 1. When it is 0 and 1, what we have to do? We have to add a is equal to a plus m. So what is a now? A ka value is 1 1 1 0 here. At the starting of step 3, it is 1 1 1 0. So we will write 1 1 1 0. What is plus m ka value? Plus m is your 0 1 1 1. Write it as it is. Add it. Add. After adding, what you will get? 0 plus 1 1. 1 plus 1 0 with 1 carry. 1 plus 1 plus 1 is 1 with 1 carry. 1 plus 1 is 0 with 1 carry. So here you get 1 carry. But here, after you get 1 carry, you will add this carry to you will shift this carry. Let's say you will discard this carry. Okay. After discarding this carry, you will perform arithmetic shift right. So this 1 will move outside, this 0 will come as it is, this 0 will come as it is down, this 1 here shift, this 0 will shift here. Now for accumulator part, 1 will move here, this 0 here, this 1 here, this 0 here, and this 0 will be replicated as it is for last bit. 3 steps completed. Now let us go to the 4th step, that is the last step, because we have 4 bits. So last bit is last round. So the string is what? 0 0 1 0 1 0 1 0 0. So comparing the q0 and q1, which are these 2 bits? 0 0. When the q0 and q1 are 0 0, we have to only perform arithmetic shift right. So after performing this arithmetic shift right, what we get? This 0 will move outside, this 0 will come here, this 1 will come here, this 0 will come here, this 1 will come here, this 0 will come here, this 1, this 0, and the last 0 will be repeating itself. So the final output that we have got is this string, that is 0 0 0 1 0 1 0 1. Now to get the actual number, or to get its decimal equivalent, what do? You just consider this part, a part and q part. A is what? 0 0 0 1, and q part is what? 0 1 0 1. Now for this particular string, convert it into its decimal equivalent, which is 21. So 7 into 3 is what? 21. So this is how we represented 7 into 3 into Booth's algorithm. Similarly, I want you to perform this for 7 into minus 3. Now I will also show you one example for, let's say, one positive and one negative, and probably both the numbers negative. So as of now, bye. I hope you have understood this. Bye bye.